Hello and welcome to our annual webinar where we discuss the results from the Liquid Biopsy External Quality Assessment Schemes for lung cancer. So I'm Professor Sandi Deans, I'm Director of GenQA, and I'm joined today by my colleague, Dr. Simon Patton, who's the CEO of EMQN CIC. And together, the two EQA providers deliver the EQA for liquid biopsy testing in lung cancer. So today we're going to discuss some of the results and the findings and observations from the 2023 EQA scheme. So next slide, please. So before we go into the details of the EQAs and the results, some of just general housekeeping issues. Your microphone's been automatically muted just so we don't have any background noise. We are recording this webinar and it should be available both on the GenQA YouTube channel and the EMQN YouTube channel, hopefully within the next couple of weeks, so you can revisit the webinar. And you can also submit your questions using the Q&A window, and we'll answer these offline after the webinar, and they'll be emailed out to all attendees. So next slide, please. So your feedback is incredibly important to us, and we actually do take it very seriously and review the feedback comments and the scores that you supply, so we can actually tailor future webinars to meet your needs. So thank you. If you could just take a little time after the webinar, you'll receive an email and a link to a short feedback survey, and we would really appreciate if you could complete that, which shouldn't take very long. Next slide, please. Disclosures. This is a non-promotional webinar organised and funded by AstraZeneca, and the views that we are sharing today are both from myself and Simon, and we've received an honorarium. Next slide, please. So what we are going to cover today is an overview of the results from the 2023 Liquid Biopsy EQA scheme, which is focusing on lung cancer. We're going to give some examples of the errors and the pitfalls that we've seen when we've been assessing the EQA, and also some guidance and practical solutions where may help where you have issues that have been identified in your laboratory or clinical service. We're going to give a bit of guidance more on reporting the results, and this is really pertinent when it comes to different clinical contexts whereby you will be performing liquid biopsy testing. And then, as I say, you've got an opportunity throughout the webinar to submit your questions in the Q&A box. So let's move on to the agenda in full then, and I'll now hand you over to Simon.
Thank you very much indeed, Sandy. So good afternoon, everybody. Welcome to the webinar. It's great to have you on board, and we hope, obviously, that we can impart the knowledge from the last year's EQA to you, with some key learning at the end of it as well. So next slide, please. So just the first part of the presentation really is just to give you an overview of what we've been doing and why, and to set some context, and then a little bit of data really around the sort of participation figures from laboratories and what sort of test technologies are used. So if we look at the objectives and format of the EQA, I'm sure many of you are already very familiar with what we do, but certainly best to run over the key objectives. So our real first primary objective really is to assess the testing accuracy and clinical reporting of laboratories that are undertaking both EGFR, and that was mandatory in this EQA, and KRAS variant testing in the context of cell-free DNA in lung cancer, so liquid biopsy testing in lung cancer, essentially. We aim to make sure that our feedback to you helps you to make improvements to your service. So we provide you with a comprehensive assessment of your laboratory's performance in the EQA, and feedback, individual tailored feedback, expert commentary from assessors, bespoke to your laboratory's results. And more importantly, also, we give you an overview of the EQA itself. So a summary report that contains detailed information about the general performance of laboratories in the EQA and specifics around the context of the testing, etc., etc. So the format of the EQA, pretty similar to nearly all of them we provide. So we asking every participant laboratory to correctly determine the genotype of the sample provided. We ask you to interpret those results, the results you get from the analytical testing, in response to a clinical referral in a clear format. And of course, clear here means making sure that the clinician at the end user of the service can understand exactly what you're saying in your report. We also assess the use of standardized international nomenclature. Again, if you're comparing reports from different individuals, you want to be sure that you're calling apples that are apples, not apples versus pears. So identical versus non-identical. So standardized nomenclature is really important in the context of clinical reporting. And also whether you provide an accurate or appropriate patient sample information identifier. So again, this idea of transferable reports between one clinician or a patient, making sure that the report conveys the information in a succinct and correct manner to the end user. Next slide, please. So just a little bit about the participation figures. So we've been running this EQA scheme between EMQN and GenQA for the last 4 years. And you can see that the participant numbers have been gradually increasing over time. So we started out with 259. We now have 316 laboratories participated in 2023. Looking at countries of participation, so the numbers haven't changed vastly. We have about 55 or 54 countries represented in the participation figures from last year. And then when you look in the detailed data on the right-hand side of the figure, where the laboratories are actually coming from, you can see that the 3 main countries of participation are China, Italy, and Spain. But there are, as I said, 54 countries represented with varying degrees of participants within those countries. So I think it's true to say this is a global EQA with a global reach in terms of laboratory perspective. Next slide, please. So our EQA samples are manufactured by us to a custom specification by a provider in Germany, Sandi. We provide the materials are manufactured under ISO 13485, so we've got good traceability, if you like, of the amount of DNA we add to every individual sample. So we provide you with 80 nanograms per mil of cfDNA in a 3 mils of artificial plasma. And the artificial plasma is important here because that allows us to ship these samples to you at ambient temperature and not using a cold chain storage approach. So no requirement for dry ice. Important if we're shipping globally. All of our samples are independently validated. So the first round of validation is done by the manufacturer itself, and they validate for the specific variant of interest that we requested. In this case, it's in droplet digital PCR. But as per normal, we don't just rest on that data. We also independently validate the sample in 3 other laboratories prior to distribution of the sample to you, the end users, the laboratories that undertake the EQA. So last year, in 2023, we used a variety of different approaches which were designed to replicate the commonly used tests in this type of approach. So we had one laboratory using a real-time PCR assay from Roche, a COBAS assay for EGFR. We had another laboratory using a droplet digital PCR approach. And finally, a third laboratory was using an in-house NGS-based assay, capture base for ctDNA testing. We also create clinical referrals that are designed to simulate real clinical referrals from a patient, or a doctor's patient sample. And we're looking at how you assess those referrals in the context of the genotypes you will be provided. So that again is I guess it's not unique, but it's a key point here. And Sandi alluded to earlier on. We're really looking to see how you handle different clinical scenarios with the samples we provided. Next slide, please. So looking at testing methodologies, we've got broken out the data here into two sections. So on the left-hand side, the graph represents the methods used by the laboratories, and then the right-hand side represents the number of laboratories using those methods. So again, it's the spread. If you look at the spread of the methodologies being used, over 50% of the laboratories, 50% of the methods are NGS-based assays. And then the next biggest proportion relates to PCR-based assays, primarily real-time PCRs. A smaller number of assays used are others, which could include a variety of different cases. Sometimes it's hard to actually elucidate exactly what the assay is. And a very small number of the assays themselves are droplet digital PCR assays. And then when you look at how the laboratories are using them, you can see that by far and away, the majority of laboratories are using a PCR-based approach with next-generation sequencing, particularly commercial assay being the next most commonly used approach. And then the others are all relatively small numbers in terms of laboratory usage. Next slide, please. So we're presenting the data from the four most commonly used approaches by the cohort of laboratories that participate in this EQA. And we have the data for 2022 and 2023. And I think the key take-home message here is really there isn't a lot of change between how laboratories are doing this type of testing between the two EQA years. So the only real shift in any significance is a few more laboratories are using the most commonly tested commercial NGS-based assay, nearly 20% of those laboratories, and a smaller number of laboratories are now using the targeted droplet digital PCR assay. So again, dropped from 9% to 5%. But the overall take-home message here, there's not a huge amount of change in how laboratories are doing the testing itself in the EQA. Next slide, please. So I'll hand you over to my co-chair, Sandi, for case one.
Great, thank you, Simon. So case one was a gentleman who was 65 years old who had presented with shortness of breath and a persistent cough. So he had undergone imaging and that a mass had been found. So he'd been diagnosed with lung adenocarcinoma, but there'd been insufficient material for further molecular testing. So a plasma sample had been sent to determine treatment options. So this sample supplied for case one had no pathogenic variants present in either EGFR gene or the KRAS gene. And surprisingly, we saw here that we had a very, very low critical genotyping error of hovering just over the 1%, so 4 laboratories, and only 1 laboratory reporting a critical interpretation error. And this is quite unusual because often when we put a case into an EQA run where there are no pathogenic variants detected, we tend to see quite a high proportion of false positive results. But this one has been answered very, very well. So next slide, please. If we go and look a bit further into some of those genotyping errors, as I mentioned, no surprises, the 4 laboratories detecting the errors were all false positives. So they either reported the presence of the most common resistance mutation, T790M, or exon 19 deletion in EGFR. One laboratory detected 2 KRAS variants in the same sample, and the 4th lab detected a third variant in KRAS. As I said, there was only 1 laboratory reporting a critical interpretation error, and they discussed the potential therapy options for a patient with an EGFR T790 variant when this variant was not detected. So this is a different laboratory that reported the presence of this variant. So within the report, their actual result did not match the clinical interpretation that they provided. Next slide, please. So the common deductions, apart from the critical errors that we've just discussed, were really the overinterpretation of the absence of an EGFR variant. And this is something that we've seen right from the start of providing these EQAs, really due to the nature of cell-free tumor DNA testing and the assays performed. When an EGFR variant is not being detected, it's too strong wording to suggest that it's unlikely, the patient's unlikely to be responsive to EGFR TKIs. You don't actually know or have any confirmation that you are testing tumor DNA in the sample. So we really need to be quite cautious when it comes to interpreting such a result. You really want to recommend testing of a tissue biopsy or a further repeat sample. And as I say, that's to ensure that the tumour DNA is actually being tested, and that is what you are reporting. Laboratories also failed to provide sufficient information regarding the methodology used, and really more importantly, the limitations of that method or assay that's been performed. And that's really important to ensure that the reader of the report is aware whether or not this is a true negative result, as in no pathogenic variant detected, that the tumour has been tested, but the method would be assumed and validated to be able to detect those variants. So next slide, please. Simon, a different clinical case scenario now. Do you want to cover case 2?
Yeah, absolutely. Thank you, Sandi. So case 2, slightly different scenario, as Sandi said. So here we have a patient, a gentleman, 63 years old. He's been diagnosed previously with non-small cell lung cancer. Molecular testing had been undertaken on his patients, on his sample, and they detected deletion in exon 19 of the EGFR gene using real-time PCR. But there was insufficient material available to perform further tissue testing. So he's been treated already with the first generation EGFR TKI and showed response. However, his disease has now progressed, and molecular testing for using CFDN has been requested to determine further clinical management. So in this case, what we have is a patient who has relapsed after treatment with a first generation TKI. In terms of expectations for results, so this sample contained 2 variants in the EGFR, pathogenic variants in the EGFR gene, and none in the KRAS gene. So we were expecting laboratories to detect the original sensitizing mutation in exon 19, present at 2%, as well as a resistance mutation, the T790M mutation, present at 1%. So the 2 and 1% were the specifications we provided the manufacturer. You can see that from the participant data, we're getting very close. The laboratory is detecting very close to our expectations. So we're confident, obviously, that the samples have performed well, and the variant allele frequencies were as expected. Looking at the genotyping errors, we had just over 5% of laboratories making a mistake, an analytical mistake in this case. So that's 17 laboratories that participated. And one laboratory also made an interpretation error as well, so just under 1%. Next slide, please. So looking at the critical genotyping errors, first off, you can see that the majority of the errors made by laboratories were false negative results. But if we take the false positives to start with, so we had 2 false positive results. So one laboratory incorrectly reported the presence of a different EGFR variant, and the other one incorrectly reported the presence of a KRAS variant. Looking at the false negatives directly, so we had 2 laboratories that didn't report either of the 2 EGFR variants. 3 laboratories reported the T790M, but didn't report the sensitizing mutation in the exon 19 variant. And we had a further 7 laboratories that reported the converse, if you like. So they reported the exon 19 variant, but didn't detect the the T790M variant. So the resistance mutation. There were also a couple of laboratories that reported both false positive and false negative results. So one laboratory incorrectly reported an exon 20 insertion and did not report the presence of either of the validated EGFR variants. So a completely different EGFR variant was reported. And one laboratory didn't report the T790, did not report the T790 variant, and incorrectly reported the deletion as well. So it detected 2 variants, but it reported the wrong deletion. Finally, we also detected what's likely to be a clerical error in this case, but of course it gives the wrong result for the wrong patient. So the genotype was correct, but page 1 of the report stated that a completely different patient on it. So first look from a clinician, you would get the wrong result for the wrong patient. So in the context of this EQA, that was called was counted as a critical genotyping error. Next slide, please. Looking at the critical interpretation error, there was one, as we talked about before. So in this case, the laboratory didn't state that the T790M variant confers resistance to first and second generation TKIs, but sensitivity to third generation TKIs. So the take-home message here really is really important to understand what the variant is doing to the clinical context. So the interpretation of the previous variant was wrong in the context of what the actual variant was. So in this case, really, they should have been referring to the use of sensitivity to third generation TKIs, not sensitivity to first or second generation TKIs. So I guess the key take-home message here, the issues identified from this case, which is very common in the context of non-small cell lung cancer therapy, is understanding the presence of the resistance variant indicates that the patient had an increased likelihood of obtaining benefit from a third generation TKI. Understanding the clinical context itself, so in this case, we provided you with a very clear clinical referral that the patient had previously been treated with first or second generation TKIs. So you need to ensure as a laboratory that you take that context into consideration. And another finding we still seem to see is the presentation of separate interpretations for the different sensitizing variants. So for the sensitizing variants, should I say. So splitting out the sensitizing versus the resistance variants, the interpretation associated with that. And it has great potential to cause confusion for the end reader. So our assessors are very clear that in this context, when you're trying to refer that information to a clinician, you need to summarize it all together, all your findings together, to make sure that the specific clinical context is and the impact of that on the patient is provided very clearly in one document that's easy to see in one go. So please do try to make sure that you summarize all the data together rather than splitting out the interpretation for the different variants. Next slide, please. I'll hand over to Sandi for the case 3.
Thanks, Simon. So this was a gentleman, a 65-year-old gentleman who had been diagnosed with non-small cell lung cancer. But as with the other cases, there was insufficient tumour material for molecular testing. So we were referring for a plasma-based test. So this sample contained an EGFR exon 20 insertion variant and no pathogenic variants in KRAS. So this is one of the most common non-small cell lung cancer EGFR variants, in about 4%, the third most common mutation. So it really was a reflection of what would come through the door for a clinical service. However, we see here quite a high level of genotyping errors and interpretation errors, which we hadn't seen with the previous 2 EQA cases, so hovering about the 4% mark. But what we did see was the participants who were reporting the variant allelic frequency was very much in line with the expected value of 4%, with the participant mean around 3.3%. Next slide, please. So again, deep dive into the critical genotyping errors. The majority of the laboratories were reporting 5 false positive results. And here you can see there's a complete, everyone describing different variants really, and missing the exon 20 insertion variant. We also had 6 laboratories with a false negative result. So here they did not detect or report the exon 20 insertion. And also we had 1 potential sample swap, which gave into doubt what the true result for that sample was, probably a swap with case 2, either sample or data somewhere along the processing of the sample within the laboratory. So next slide, please. If we also start looking at the reasons for critical interpretation errors, here you can see there's a real theme here of 11 out of the 12 laboratories incorrectly indicating that this exon 20 insertion in EGFR increases the likelihood that the patient would benefit from EGFR TKI therapies. And we know that patients with this particular EGFR variant is not sensitive to TKI therapy. So really that is an incorrect patient interpretation to provide. We also had the 12th laboratory discuss the potential therapy options for a patient with a T790M variant when this variant was not detected. So similar to the previous cases that we've been talking about, particularly case 1, this patient did not have this variant or mutation, but the clinical interpretation for that variant was provided. One of the issues that we picked up on this particular EQA case is something that really gives evidence to why we have been saying not to use specific drug names in reports, but to refer to drug classes rather than specific products. So many laboratories discussed the potential clinical benefit of one specific drug. And in October 2023, last year, the manufacturer had issued a press release, and here you have the references where you can see that press release, saying that they were working towards a voluntary withdrawal of the drug in the US. And that's for adult patients with EGFR exon 20 insertion mutations specifically, both in the locally advanced or metastatic phases. and they had an intention to initiate voluntary global withdrawal. So again, it was about very much any advice for this specific drug to be used for this patient in a report was actually going to be not appropriate after this global withdrawal of the pharmaceutical target drug. So again, as I say, a good example why you should not use specific drug names in reports, but refer to drug classes such as TKI therapies. So next slide, please. So another common issue that came up from this EQA case in particular was about one particular testing methodology. So 16 laboratories were either using the Oncomine lung cell-free total nucleic acid research assay or the Oncomine pan-cancer cell-free assay, and they all did not report the presence of this insertion 20 variant. However, there were also other laboratories that did use these assays and did report the presence of the variant. So because this is quite a large number, it sort of indicated that there may be a common theme as to why this was the case. So we did a bit more of a deep dive and some investigation. And we found that even though the region of EGFR, so exon 20, was included in the actual sequencing of the assay, it was not actually in the hotspot file required to call variants using the KIT's bioinformatics. So it was present in the sample, it was detected by the actual wet sequencing, but the bioinformatics did not prioritize it and call it. So it shows there that you really need to understand the limitations of your bioinformatics, not just the limitations of the methodology itself. We also found, and that's probably reflected in the higher degree of genotyping errors here, was that many laboratories didn't provide sufficient information on the report to make it clear whether their assay would not or would detect all the variants in exon 20. So therefore, they received deductions from their interpretation scores because it was assumed that if it did not state in the report that they did not detect these variants, then they should have detected them. Therefore, due to the testing that they had performed, then they should have reported the presence of the exon 20 insertion. So again, it's very same really common theme, understand the limitations of your assay and make sure that it's stated very clearly on the report so the reader of the report understands whether or not a variant could have been mixed just due to the testing strategy. So next slide, please. Simon's now going to come up with a couple of the observations from all of the EQA cases from this run. Simon?
Thank you, Sandi. So yes, we've got a couple of slides now, really summarising sort of general observations from the EQA across the cohort laboratories. And the first real observation is relating to the use of standardised mutation variant nomenclature. We have been advocating as EQA providers for a long time the use of standardised nomenclature. And this year, 6.3% of laboratories, so about 20 laboratories, received deductions for using either the incorrect use of the nomenclature or not using the nomenclature itself, which is considerably lower than previous years. 18% was what the figure was for last year. And I think it shows the growing trend, if you like, of laboratories being much more systematic in how they actually report variants moving forward. So it's really good to see. There's a real positive improvement and the EQA is definitely having an effect, I think, in that respect, and we're seeing much more use of standardised nomenclature. There are a few other take-home messages from it, though. So we still see quite a lot of laboratories only reporting the results at the amino acid level, but of course, in many cases here, we're using a DNA-based test. And the variants should really be described in the terms of the nucleotide changes that have been identified, and ideally with the predicted amino acid change as well. So we know that some commercial kits only provide results for the amino acid change, amino acid level, but it's quite often possible to determine the nucleotide change of some of the variants from either the literature provided with the kit or using an online tool, for example, such as Cosmic. So our recommendation is that, as and will always still remain, is it's important to include both. The DNA change should be on the report as well as the predicted protein change. So you should state where you should clearly state on the report where it's not possible to provide the actual variances after it's tested. But as I say, the data is now showing that many laboratories are really doing a much better job of that anyway. So it's becoming smaller in terms of a problem, but we still see it as a problem. Next slide, please. Another common observation with respect to variant nomenclature is really the use of laboratories using more than one reference sequence per gene. The guidance is really very clear that you should be only using one reference sequence per gene. Both EMQN and KRAS support use of the main initiative, whether that be the main select or main clinical plus transcripts. We are pragmatic, I suppose, in our approach to this, because we do realise that the main initiative is really we've been pushing for many years the use of LRGs. So it's still perfectly acceptable for us to use the LRGs, even though these are no longer supported. But RefSec or ensemble transcripts are now what are specified by the main initiative and therefore now preferred. But don't forget the whole idea here is to have either like more of a stable transcript associated with a particular gene. So the number of laboratories receiving deductions for not providing the right information in relation to reference sequences hasn't really changed between this year and last year. So 12.7% of laboratories received deductions for not including a reference sequence on their reports. A little disappointing to see, given the fact that there has been a significant improvement in the nomenclature used. But we will keep pushing and advocating the use of one reference sequence per gene. And of course, if you start to follow the main initiative, it now uses a main transcript associated with that. So we hope to see improvements to that in future years. Next slide, please. Another key trend, and Sandi kind of alluded to it again in case one, really, when we have provided a sample with no variants in it, is how laboratories report the limited detection. So again, we are looking at cfDNA, but therefore by its very nature, the amount of tumour DNA present in that sample is very low. And so how you report the limited detection of your assay is really important in this clinical context. So there were a large number of laboratories that failed to provide adequate details on the limitations of their assays, and inconsistencies in how if they did report it, how they actually measured that between in the report. So some laboratories either report copies per mil or a percentage, but of course these are not equivalent. So if we're looking at copies per mil, it will obviously give you an indication of the minimum number of copies of DNA the assay can detect, whereas the percentage value indicates the sensitivity of the assay in detecting a variant in a background of wild-type DNA. So the two are different, and ideally, your report should include both values as determined by your in-house validation and or verification process prior to the introduction of your test in the routine clinical use. So we would strongly advocate to laboratories to really try and get on top of the limitations of detection of their assay and make sure that they report that appropriately in their report. Next slide, please. Finally, we'd look at performance. Everyone's always interested in how it's going up between each different year. So the take-home message here is it is definitely improving. But there is still room for improvement. So on the left-hand side, you have the data for the scores associated with the 4 different years of scheme provision, 2020 to 2023, for the 3 categories that we assess, both genotyping, interpretation, and clerical accuracy. And if you remember back to the way that the EMQN and GenQA assess our reports and report them, we're giving laboratories a score out of 2. So 2 is perfect, and 0 is generally a critical error. And you can see that the mean scores over time have been improving. Certainly for genotyping, there's definitely been improvement. So we're getting closer to the magical 2. We never see the magical 2, of course. It's a mean score. The interpretation is obviously much more subjective and very much dependent on the clinical context that we provide in the cases that we give the laboratories. So we expect to see quite a lot more variability there, and we are certainly seeing that. There's also a context there of a language. We obviously require most laboratories to report back in English, and of course, that's not the native language of many of the laboratories. So we fully expect to see variability in the score for interpretation. But generally, it's getting closer to the 2, which is good to see. And clerical accuracy generally hovers around 2, We don't like to see get too low, because obviously that means the way you're conveying the information back to the patient is probably less than optimal. Looking at the performance laboratories over the 4 years, so it's not uncommon for us to see a very high genotyping or analytical error rate in the first year of an EQA, generally reflecting the new test and the unfamiliarity of the laboratories doing that type of test. So in the first year, it was nearly 30% of laboratories made a genotyping error, and a very, very small number made an interpretation error. Interpretation in the first year is always marked a bit more subjectively anyway, so we would expect to see a slightly lower level. We are seeing the error rates coming down. So in 2023, we had 10.4% of laboratories made a genotyping error, but it's still high. And typically across most of the EQAs that either GenQA or EMQN run, you would expect to see a sort of trending error percentage of around 2 to 3% for an established, well-established technology or approach. So we are seeing error rates that are about 3 times higher at the moment, and it hasn't come down hugely in the last 3 years. I think really just generally reflecting this is a complex test, and the laboratories, understanding the complexities and the nuances of small amounts of DNA and a large background of genomic DNA, etc., and the implications of how you actually measure that and assess it is complex, and it requires a good understanding of how the test works, and good samples, a whole load of caveats there. But more work to be done, I think, is the take-home message. And we're also seeing a slightly higher percentage this year for the interpretation error rates. But I think Sandi alluded to the reasons behind that, which is really predominantly coming from case 4, which was quite an interesting scenario, but very common variant that would be found in the context of lung cancer testing using liquid biopsy sample. Okay, next slide, please. Finally, a few acknowledgements. This isn't the work of Sandi and myself. This is the work of a very significant number of individuals, and predominantly the work. We celebrate the work of our assessment team that have really helped us to deliver this work to you. So you can see there are many people involved in this in delivering this EQA. It's a very large EQA scheme and a very diverse number of individuals helping support it. So we thank all our assessors and scheme organisers for doing so. But also, we can't do it without the support of our own internal teams. So a big thank you as well to the GenQA and EMQN teams, to Jenny, Emily, Arthur and Mel, who've actually delivered the EQA, not myself and Sandi. We've not done the work, we're just talking about it. So thank you to our colleagues as well for all their work in supporting it. But most importantly, thank you to you, the participants who've actually supported us and taken part in the EQA. We hope you found it very useful and helpful to you. We hope we've provided with a good overview of what's taken place this year, and that you will continue to support it in future years. Now, I think, Sandi, if I'm right in saying we don't have the ability to provide direct feedback today on the Q&A, but we will, if you submit your questions in the Q&A box, we will answer those remotely afterwards and get back to each individual participant if you've got any questions and answers. So do please submit your Q&As. We've got a couple come in so far. It'd be great to have a few more, but if you haven't got any more, obviously you can come back to us at some stage through either the EMQN or GenQA mailboxes and ask a specific question to us afterwards. Sandi, do we have anything else you want to cover?
Yeah, no, thank you. Simon, just to add my thanks as well to the whole team and the participants as well. And also just notification that the runs continue annually. So if you're interested in participating and haven't yet signed up, registered, then please go to either EMQN or GenQA's website, and I'm sure you'll be very welcome to join the next 2024 EQA assessment. So thank you very much for joining us, and we will answer your questions as they're coming in now. So thank you very much, everyone. Bye-bye.
Thank you.